everyone, and welcome to Talks at Google. My name is Alexis Ryan, and I run ad safety partnerships here at Google. Today, we will be joined by award-winning quantum physicist Shohini Ghose to discuss her new book called Her Space, Her Time: How Trailblazing Women Scientists Decoded the Hidden Universe. The book will be officially released tomorrow, October 17th, with the MIT Press. We'll kick off with a discussion and save room at the end for some audience Q&A, so remember to add your questions below on YouTube. Before we jump in, let me tell you all about our esteemed guest. Shohini is Professor of Physics and Computer Science at Wilfrid Laurier University in Canada, Director of the Laurier Centre for Women in Science, and the NSERC Chair for Women in Science and Engineering. She is the recipient of several awards, including a TED Senior Fellowship and selection to the College of the Royal Society of Canada. And in 2019, she was among 25 women scientists worldwide featured in a UNESCO exhibit in Paris. In her book, Shohini has illuminated the work of many brilliant women scientists throughout history. And today, I have the privilege of shining a light on her. Please welcome Shohini Ghose.
Hi, Alexis. Thank you so much for having me.
Yes, thank you, Shohini. We're so happy to have you here, and we know that you're very busy with the soon-to-launch of your new book coming out tomorrow, so we appreciate you taking the time. And, just to kick us off, it's not every day that you meet someone who's a quantum physicist, an industry speaker, and an author. So to get us a little bit familiar with you, can you tell us, how did you end up following this path and specifically getting into the field of quantum physics?
Sure. I wouldn't say it's very well planned, but I guess my story starts back in India, where I was born and raised. And one moment that does come to mind that I think must have had quite a role for me is that I remember very clearly as a little kid, we didn't have a lot of TV back in those days, but there used to be one English language American show every Sunday morning, and it happened to be Star Trek. So I think I was one of those early Star Trek nerds, and that made me want to dream of being an explorer. And one thing led to the next, and then eventually I heard about Rakesh Sharma, who was the first Indian astronaut to go to space. And I'm like, wow, so you can do that? And, as an Indian, we can go out to space. So that made me dream a bit bigger. I also loved, solving mysteries and, all these detective stories. And then I figured out that, the biggest mystery out there is the mystery of the universe. So that led me to thinking, okay, how do I get to do that and be an explorer in this bigger context? And that's how I started out and explored. And once I got into physics and understood just how weird and wonderful things are, there was no going back. So I feel like it's one of those moments that discovering something is you can't undiscover it. So now you just have to keep exploring.
Yes. And we can definitely see your passion come through for the world of physics in your talks that we've seen. By the way, Shohini has some great TED Talks, Beginner's Guide to Physics, that has many millions of views and all kinds of great industry discussions out there. But Shohini, following the path of getting into physics as a woman wasn't always very easy or straightforward, right? Because it's often been a male-dominated industry. And so in your book, you describe this moment that really resonated with me. You talked about how your university physics professor would greet your class with "Good morning, gentlemen." And it was completely oblivious to your presence in the classroom until you made a joke about it, right? To kind of bring up the fact that you were indeed there. So, it's, even though you had this great passion for physics, tell us about how experiences like this shaped you.
Well, they leave a mark, of course, which is why I remember it all these years later. And I think lots of women and people who find themselves being in the minority in different situations, they remember those little things. And we have this word for it, which we call microaggression, but it's not actually a microaggression. If it were micro, we would forget it. So I don't think these are, and over time they build up. And I know for me, for sure, it left this impression that I'm alone and I'm isolated. I didn't know that basically all women and underrepresented minorities in science feel this way. We feel
Mhm.
isolated because we don't see many of those from our communities being well represented, or even having the scope of participation that you might
Right.
want to have. So because of that, I think it's obviously important to address this issue. For me, the impact, which is I think very common, is that I started questioning whether I should
Mhm.
be, if I really should be in these classrooms. Maybe I don't belong. Maybe there's something wrong with me. These questions always come up, and it took a lot of time and self therapy and a lot of investigating in a more scientific way. What are the reasons that there is this sort of difference between the numbers of women, for example, in physics classrooms and other groups that we don't see as often represented in these situations? I try to explore it more as a science problem, as a scientist. What do we
Mhm.
know? What are the metrics? What are the experiences? What are the possible reasons that this is happening? And that actually allowed me to move forward in a way that helped me overcome all these feelings and realize that we can actually make a difference. And no, it's not on me, and it's not about on all the other women who feel this way. It's about all of us
Right.
building that inclusive environment where we can all participate to the level we need to.
Absolutely. And I think, as you said in your book as well, there's no difference in the capabilities of women and men, in terms of these types of fields, right? There's nothing that one gender has over the other. It's really been more of a social construct.
Mhm.
So, on that subject, let's dive into the book. Your book is described as telling the inspiring stories of long overlooked women physicists and astronomers who discovered the fundamental rules of the universe and reshape the rules of society. That is a lot to unpack. So, what was the inspiration for this book? We'd love to hear more about how you came to create this.
Sure. As I was saying, once I started engaging with this question of why do I feel alone and why am I isolated
Mhm.
and where are all the other women, I started looking into it and trying to discover whether or not there have been others involved in physics. And the more I dug into the history of all the big physics discoveries, the more I discovered, of course, there were women involved in almost every area, or whether it's physics or other areas of science. But certainly in physics and astronomy, there's been huge amounts of women involved, but they just haven't been included in the story that we tell. And so for me, that was really the start of this journey where I started, building all these collections of stories and telling these bigger stories in my own classrooms. When I'm teaching about physics, I do try to make sure that we have this more inclusive story we can tell and not leave out people just because they don't happen to fit this image we have of who a scientist is. And doing that over the years, I also broadened my scope and looked
Mhm.
beyond just what we know of as Western based science and physics and astronomy, and wanted to know what happened all around the world, especially from my own background as an
Yes.
immigrant to the US and then to Canada. So I found stories of women from my own community in Bengal where I didn't know their names when I was growing up. And
Wow.
yeah, that to me felt like such a loss. And I didn't want other Bengali girls growing up in the future not knowing these incredible women. So all of that led me eventually to think about what could I do to
Right.
change this. And then, of course, the pandemic happened. And that was, of course, a terrible time. But for me, it also ended up being that time that I needed to sit
Yeah.
down and just collect these stories and write them.
Absolutely. Definitely a great use of that time, a difficult time, but you really made the best of it, I would say. And so what was your process for, you talked about discovering and kind of uncovering all of these different women scientists throughout history. What was the process for writing the book, right? Because I know you have different categories of different discoveries over time. How did you come up with the structure?
Yeah, I was thinking about that for a while before I started, and I realized I really wanted to lead with the science and
Mhm.
tell the stories of these women as scientists and follow their journeys of discovery, their passion for what they were uncovering. So that's why in the end, what I wanted to do was structure the book from the point of view of the scientific discovery. So each chapter is around actually a scientific topic, a theme like
Right.
particle physics or the Big Bang or space exploration. So those kinds of topics, and that actually allowed me to tell more of a story about that discovery and how these women's contributions led to the impact they had, not just what they discovered, but why they were important and how they did it. And that's where I was able to pull in all of their personal stories, because, of course, all their stories are inspirational because they did all this amazing physics and astronomy, but also because they did it while dealing with huge barriers and biases and challenges that they overcame somehow.
Right.
So that's what I was trying to get to in the structure of the book, where I think
Yes.
there's a story about scientific discovery, which each chapter focuses on a different type of topic in science, but overall there's also the story of these journeys of the women and the patterns of the kinds of struggles they had to overcome and how they got to where they did. So there's all kinds of
Absolutely.
lessons, which I know I learned so much. So I felt
Yes.
I really wanted to share that.
And I've so enjoyed reading about these stories, and it was really eye-opening to learn about some of these women who were doing incredible work, yet being paid half of their
Mm-hmm.
male counterparts, and in certain cases not being credited,
Mm-hmm.
and really had to fight for that. So could you tell us maybe a couple of stories, and I know it's hard to choose, but a couple of examples of these women for our audience that you'd like to highlight?
Of course. I mean, there's so many. But I was just recently actually visiting in Florida for one of the launches at the Kennedy Space Center, and I was wandering around there. And there's not a lot of women that you will still find featured in the history of space exploration. But so that's something that I do address in the book. So one of the stories I'll quickly tell that is mentioned in the book is about the early days of the space program in the US, which as we all know, there was this space race that happened, between the Soviets and the U.S. And the person in the U.S. who was leading the space program was in fact this German scientist who, after the war, had come to the U.S. He was brought actually to the U.S. to start the space program. He's pretty famous, well-known scientist. His name is Werner von Braun, and he was brought to the U.S. because he was in charge of the German missile program. So, in fact, it was those missiles that were eventually repurposed to be the first rockets in the space program. So he had this, team that he was working on to try to be that first, first team to launch any kind of satellite into orbit around the Earth. And of course, in fact, U.S. didn't win that race because the Soviets launched Sputnik. And so everybody was, getting into high gear in the U.S., trying to at least be launching the US satellite as soon as possible. So that first mission that was successful on the US side was Explorer 1. And the team that was working on this under von Braun, there were two parts to it. One team was looking at the actual stage 1 rocket, and then the second team was trying to calculate when the stage 2 rocket had to be fired, which is what puts the satellite into orbit, and it has to be fired at exactly the right time. Otherwise, if it's too early, things will be bad, and if it's too late, then it won't go into orbit. So very, very tricky calculation. Keep in mind, by hand, early days of computing. There wasn't any data that you can use and say, oh, these are the standard numbers for fuel burn rate and speed and velocity. Everything was new, so you had to
talk about a lot of pressure, right?
Right?
Yes.
Best guess. You have one shot. You got to get it right. And the Soviets were already ahead, so even more pressure. So the person who was in charge of that team doing that second stage calculation was this woman named Joyce Neighbors. And she and her team, of course, we know now, looking back in history, they did get it right because the mission was a success. And that was, of course, an amazing achievement, which actually the news didn't report her contribution at the time. It was von Braun and the other, men who led the mission. She and many other women who did contribute were not mentioned much at all in the media. But internally, she was given this huge credit and honor of signing the mission chart which,
Mhm.
von Braun would normally sign as this, sort of honor that it was successful. So she was invited to sign her name beside von Braun's name, but they told her, don't sign your full name because a woman's name would undermine the credibility of the chart. So
Wow.
even in this moment of huge success, her gender was always an issue. And she did actually only sign her initials. And she went on to have an amazing, successful career, continued in the space program, was involved in many other missions. But yeah, this was the level of bias they were dealing with. And I don't even know how she kept calm and was able to continue. But many
Yeah,
of these women had this wonderful resilience, and their passion for
absolutely.
science overcame these kinds of clear, like outright, sort of experiences where this is something which, how do you get over that and say, yeah, I'll continue to work with these men on the team who don't even let me sign my name.
Right.
But
And
she just,
this was a bit of time ago, but it wasn't that long ago,
no.
right? It really wasn't.
Yeah, that is
So
mid 50s. So yeah, not that long ago.
yeah, really, really impressive, the amazing contributions that were made, but also this other side of it, which is, the challenges that they had to work through. So I want to talk a little bit about, you in your book, obviously, you're really highlighting all these women throughout history. But I think right now we're at this pivotal moment where we have the opportunity to change that, change that bias and change the difficulties that women had to experience in the world of physics and STEM. So in your book dedication, I love how you framed this. You said this book is for all the women scientists whose names are lost to history, and for all the women scientists to come who will make history. So how do you think as a society that we can make sure that women thought leaders in STEM or other fields are recognized for their contributions?
Boy, that's a complicated problem, of course, and it's something that actually there's already been lots of discussion around, and we've been trying for many years, decades now, to change those numbers, especially in physics and astronomy, where currently the proportion of women in the field is about 20%. And it
Mm-hmm.
hasn't really changed much over the years. There's been some small increase, but not very much. And if you dig even deeper and look, among women, who are the women who are participating, you'll see there's a huge difference between women of color
Mm-hmm.
and white women. So there's been really almost no increase in the number of women of color who are participating in physics and astronomy. So although we've had initiatives and things like camps for girls and
Mm-hmm.
programs for professional development and work-life balance and so on, they have not really impacted the numbers. And unless we have numbers, how are we going to actually see women succeed and have those role models and recognize their achievements? So I think part of the problem is, as I said, for me, what helped was to think about it not just as something that is that is one off in terms of here's a camp I can run on, here's one
Mm-hmm.
outreach program, but to think of it holistically and structurally and systemically, which is exactly how we
Mm-hmm.
think about many major global challenges. This is a global
Yes.
problem. These numbers are skewed all around the world, doesn't matter where you go. And there's been lots of surveys which show exactly what are the challenges that women scientists face: less
Mm-hmm.
resources for their work, less acknowledgement, less opportunities for progression up the career ladder, more time spent on home care, more time spent
Mm-hmm.
on childcare. It's not a surprise. We know what the issues are. And yet, what we are doing to address it is always fixed on, okay, let's have a camp for girls, or let's make work-life balance workshop for the women. And to me, these are all about aiming at the women, fix the women, rather
Right.
than look at fix the system.
Yes.
So no amount of camps for girls is going to change biases against those girls. Similarly, work-life balance will not help unless everyone with, our men who are partners in our lives and our households don't also step up. So I think part of the reason we are not seeing a lot of change and not acknowledging what women can do, and these biases are not changing, is because we're not providing these support
Right.
systems. So I think it will really help to move away from the fix the women kind of approaches and
Mm-hmm.
more towards structural policy changes, address what the environment is. Why, if women are not having the resources to succeed, how do we get them those resources? If women don't get the grants, why not? If women are not being acknowledged in their achievements that they've already had and celebrated and getting those awards and winning those Nobel prizes, why not? Let's address
Right.
not the women as in let the women do better. No, let us think about why we are not actually celebrating women in the same way as men. So that's
Yes.
what I think would help more.
Well said, Shohini. I think that you nailed it there. And can you tell us a little bit about what you do at the Laurier Centre for Women in Science?
Sure. Yeah. So this was something that I founded about 10 years ago now, with exactly this approach
Mhm.
in mind. That what if we could create a hub where we can bring women scientists like myself to the table to speak with and learn from those who are social scientists, who study
Mhm.
gender issues, psychologists who understand human behavior, early education specialists who can speak towards what happens in classrooms and how do students learn, uh, talk about things like what is a science identity and those kinds of questions, which often physicists like me, of course, we are not experts on that.
Mhm.
And we know our physics, but our lived experiences also give us some level of knowledge of how all of this works, and we learn to navigate it. But if all of us could be on the table at the table and all these different experts could exchange ideas, we could build evidence-based kinds of initiatives to move forward. And that's what the center started focusing on, where we did work with social psychologists and education specialists and policymakers and so on. And over the years, that has been pretty successful, to the point where now we've engaged with partners nationally across Canada, and recently the government of Canada launched this new initiative called the Dimensions Charter, which is exactly about institutions across Canada, academic and other research science-based institutions, that commit to this charter of structural and systemic change. And there's a program that provides funding from the federal government to be able to enact what we know are well-tested initiatives that do work, and to try to move away from these initiatives that perhaps don't work and might undermine what we're trying to do. So
Yeah.
that's what we've been working on.
Amazing. Well, thanks so much for all the work that you do with the center, and I'm sure that that will make a big impact as we move to the future. Also, sounds like an incredible working group that's involved in that project. And so, I wanted to ask you, Shohini, because I know that you probably didn't do this journey alone. You haven't gone it alone. So I want to talk to you a bit about mentors. And at Google, we talk a lot about the value of mentorship and also sponsorship, especially with our Women at Google group, which I'm a part of. Was there a mentor that had a major impact on you and your journey?
Um, yeah, so I don't think anybody does this alone. And for me, certainly on the physics side, as I was trying to navigate my way up as a grad student in my early days, when I had some professors who, as you mentioned, I described, didn't really see me, often I felt like I should just quit, as I was saying. And then eventually I met this one professor who said, hey, why don't you try, do a one-term research project with me? If you like it, maybe we can continue. And what was amazing to me is that he didn't, for the first time, and he didn't sort of um, put me in a box, right? He just saw
Mhm.
me for me, right? So that was really very important to me. And we did this research project for a term, and that actually did grow into a bigger project. And eventually, I did my PhD under his supervision. So he was, I think, for me, a very, very important mentor. And he actually just literally prevented me from dropping, because I had told myself, okay, I'll do this one term project. If it works, great. If not, I'm out. I'm going to go find
Wow.
something else.
Yeah.
So if it had not worked, that would have been it. So that was a huge, big moment. And, he's still somebody that I am very close to and, look up to. And I will forever be grateful to him. So I
Yeah.
think I was lucky to have him as a mentor. There was others too in the physics community who have absolutely been supportive. I've had sponsors too, and I think it's important to clarify that mentoring is important, because you need those guiding voices and those who will support you. But sponsors actually share their platform and will will actually put you forward for opportunities that will be much harder if you did it alone. So it's not just about advice, it's about action too. So I think women are
Absolutely.
often over mentored and under sponsored. So
Right.
I think we do need to increase that sponsorship piece. And I will mention again, to go back to this point, over the years I've also realized we've focused so much on mentoring these days that we've perhaps lost this perspective that no amount of mentoring will fix the broken system. So unless we also work on creating an inclusive environment where when we mentor women, they do get a fair chance to succeed, right? If you're in an unfair system, yes, you have mentoring just to help you navigate the unfair system. It won't change the unfair system. So I want to make sure that we continue with the mentoring and the sponsorship, but keep in mind that these are band-aids. They will not fix the actual structural systemic problems. So I hope we can also put more of an effort on, policy level changes and culturally biased changes, and look at things like implicit biases and things like that, which mentoring is not the answer to. So it's a bigger problem.
Absolutely. No, I think the two are absolutely, important to have hand in hand. And I like that you said, it's not that we need to fix the women. Obviously, mentorship is super helpful, but looking at the broader system is critical here. And I also loved how you talked about, your mentor that really made that major change in your life. And I think it's so helpful for everyone who is, either looking to be mentored or maybe who is mentoring. The importance of those moments and that support can really change the trajectory of somebody's career and their life. And I'm so glad that mentor encouraged you the way that they did.
Thanks. I want to mention his name. It's Ivan Deutsch. So thank you, Ivan, wherever you are. He knows how important he is. Yes.
Absolutely. I think a lot of us have had those people in our lives, and you can look back and think there was maybe a fork in the road, and you're so glad that they helped you to steer in that direction. So now I want to pivot a little bit to talk about your work in quantum physics. And also a quick reminder for the audience, please add your questions down below on the YouTube link so that we can also get to that shortly. So, Shohini, in a recent interview that you did with Conversations at the Perimeter, you shared something that struck me. And you said, I'm a big fan of uncertainty, which I think is a unique perspective because most people are really uncomfortable with it, whether it's in their careers or their work or their personal lives. But how has your exploration of quantum changed your perspective on uncertainty and the unknown?
Well, thanks for asking that, because I think it is a really important aspect of what I've learned from being a physicist, particularly a quantum physicist. So in quantum physics, of course, uncertainty plays a huge role because that is the fundamental, nature of this theory that we've learned, and which has been quite a learning process for us in physics. Most of us are still not quite comfortable or really deeply understand what this all means, because the theory is essentially telling us that there's just no way to precisely know everything about a quantum particle like an electron or a photon, because it's just fundamentally not knowable. So no matter how hard you try, no matter how precise your measurements are, you just can't pin it down perfectly. The laws of physics don't allow it. So that's really deep, because on one hand, it's just weird because it's not what we experience in our everyday lives. What does it even mean not to pin down something and have this fluid sort of properties, physical things that we can't quite know if they even exist at all? So that's really weird. But on the other hand, it's also really exciting, because it means that there's always possibility. So what we think of as not knowable is, to me, means also what's possible.
Right.
That there's more than one answer possible. So for me, that reframing was quite interesting, because it means maybe we should think beyond what we have been doing all these years, especially in fields like computing, which is, of course, very binary. It's all about zeros and ones.
Right, and very precise, right?
Very
so this is a complete diversion.
Yes. So yeah, zeros, one, precision, You can calculate everything in this binary way, but I think it's extended beyond just calculating things, right? We are kind of very binary, yes or no, right or wrong, up or down. So we love our sort of endpoints, and we kind of miss all everything in between. And I think in studying quantum, particularly in the context of computing, we've learned to fill that in, as in it's not just zero or one or zero and one, it's everything in between, which is what we call a superposition and quantum bits. And that's really where the uncertainty manifests itself in quantum computing. And not only that we're filling it in, but we realize now that this bigger framework of quantum computing is more powerful in some ways. There are certain problems we know that quantum seems to be able to calculate more efficiently. Maybe in the future we'll find that the standard way of computing, perhaps there's another algorithm that also works. But as of now, that quantum is actually this bigger version of regular computing. So by moving away from binaries, binary thinking and precision and certainty, and including uncertainty, things have become more interesting, more exciting, and more powerful. And that's a lesson. And then applying that to my own journey, who could have predicted when I was just that kid growing up in India? There's no way I could have certainly known that I would be where I am today. And that sort of wandering, meandering path to me also, is something where I realized, things were uncertain. And by having many possibilities, I found a way that perhaps was where I needed to be without knowing I needed to be there. So instead of taking that straight line, how many people actually take that straight line to where they need to be? So it's actually quite common. We just don't think of it perhaps very explicitly. So for me now, I want to embrace that more explicitly and say, yes, let's be open to uncertainty and adapting to things we don't know, because the universe is literally telling us that we can't know everything. So let's not be know-it-alls, I guess, is what the universe is telling us.
I love that perspective. And I think, listening to that is so refreshing, whether it's in the study of quantum physics or in our day-to-day lives, right? And I think probably so much of what we even consider to be certain, we don't actually know. And so I think, having that perspective probably helps you navigate a lot of unforeseen or unknown challenges with a different level of fluidity and flexibility that I'm sure makes you even stronger.
And it feels empowering, you're right. So that's what you meant, feeling stronger. That's really important, because you don't have to always choose between just two things or know exactly where you want to go. It's a little more liberating and therefore more empowering to give yourself that space for many possibilities. So
exactly. At Google, we talk a lot about navigating ambiguity and uncertainty, which can be challenging. But I also think it means that we're doing something new, which is really exciting. And so we can embrace that and figure out how to put certain structures on things, but also leave certain things unknown, and then keep working through them. So I want to talk a bit about the future of quantum, because I know you have some great perspectives on what quantum can do for our society. So what's one potential future application of quantum computing that you're most excited about? I've heard you speak a bit about potential for privacy and security applications, which I think is fascinating. But what are you most passionate about for the future of quantum?
Wow. So there's a lot there. I think we're in the early days of discovering exactly what we can apply this new type of technology and thinking to, this new framework of computing to. We do know, of course, that there's possible ways of building a new type of encryption that's not based on actual computational security, which is about doing hard math problems, and instead moving into a quantum-based security system where you encrypt your information in such a way that to crack the key and break somebody's encryption, you'd have to break the laws of quantum physics. So to me, that's of course very exciting. Just that shift in thinking and understanding the power of these quantum kinds of approaches to computing and information processing. And that really is exactly what we just discussed, that the power of uncertainty would be behind that kind of encryption. So that's, of course, very exciting. But keep in mind, any such application has good and bad, of course.
Right.
That, there's pros and cons. Of course, privacy and security for all of our data would be lovely, but it also means that everybody else, including the so-called bad guys, would have access to privacy and security. So how are we going to protect against those kinds of applications? So there's that. But it is still quite interesting, even from a scientific point of view, which is what excites me. The other thing that I think is very much an urgent need, obviously, is global healthcare.
Mm-hmm.
And part of what could be a potential use of quantum computers, if we can figure out how to really scale them efficiently and build, we don't need like super large scale quantum computers, even mid-level quantum computers that could work fairly cleanly, meaning with, without too much errors, and, with run times that are reasonable, could perhaps be used for doing calculations around understanding structure of certain types of molecules that might be good for pharmaceutical development, or maybe even for building better materials that are more energy efficient, things like this. So I think those are more exciting applications because they don't require us to build a very, very large scale quantum computer. Maybe even mid-level, next generation perhaps, and not just very, very far off generation quantum computers would work with what we already have, which are very, very good regular classical computers. And that kind of a hybrid approach may unlock even small steps towards, something that would be useful in the future. Even if we could cure one or two of these so many global healthcare challenges we have, that would be wonderful and worth all of this effort. And I guess I'll say personally, as a theoretical physicist, all this work, even if we end up having just one or two things that are really useful, to me, knowledge is knowledge. And I'm really excited to see how thinking about applying quantum uncertainty, which is really underlying a lot of this quantum computing approach, what does it teach us about what the universe really looks like and how we should think? So that to me is really deep, and we're learning whether or not we apply the technology.
Yes. Well, thank you for sharing those thoughts, Shohini. I think, I like your concept of let's start with things, even in a kind of smaller scale, kind of quantum application, just so to drive adoption and see if we can make incremental improvements versus waiting until we've perfected something to apply it. I think is a great perspective. So before we move to a little bit of audience Q&A, which is just another plug, if anyone has any other questions for Shohini, please add them in the chat. Before we move on, what is one takeaway that you'd like today's viewers to remember, or anything that we didn't cover that you'd like to highlight today?
So I guess I'll go back to the book, and when you go through the stories of all these women, one thing that's very common, a pattern, is that they faced a lot of skepticism, a lack of real respect for their abilities and their work. So I think one takeaway, and that's something we all can do better at, is let's trust women. Let's find a way to believe. And this is not just within science, as you know, this is coming up in many, many other contexts as well. We have to believe that women know what we are capable of, what our strengths are, what our skills are. So often we don't hear them the same way we hear perhaps some of our other colleagues. So we could all take a step back and make sure that we do that. We listen more, we hear better, and we trust more. That would be wonderful.
I love that. Thank you, Shohini. All right. So I think we're going to move on to the Q&A. I see we have a few questions from our audience. So I'd love to jump into that. All right, so Farah Simone asks, what was the most surprising discovery for you while writing the book?
Wow. So all the discoveries were deep, as in from the physics side, as I said, I'll say generally, my discovery was there's actually a woman involved in every major discovery. So that's really great. One particular story I'll mention, which I didn't know about, and it was really surprising to me, especially because it's involved an area of the US that I know fairly well. So I did my graduate work in Albuquerque, New Mexico. And so we used to love just traveling around that area, me and my friends, exploring all of the beautiful desert landscapes everywhere. And we'd often go by this place called Shiprock, which is exactly what it sounds like. This giant, enormous rock in the middle of this flat desert, and it looks like like a ship, that's just stuck in the land. It's just rock, of course. And I used to think it's like a crash landed spaceship. Turns out that that's kind of relevant because Shiprock is actually a Navajo reservation area. And going back to this, when I was researching the chapter about space exploration and the early days of the space program in the US, what I discovered, which was really surprising and amazing to me, was that Shiprock was also the location of a factory for making computer transistors and chips that were used in the very first computers that were being commissioned by NASA to be put on their missions, because of course they needed really good computing power, and they were one of the earliest adopters of this technology, because before that there were the computers existed, but there were these large machines with the vacuum tubes, and they took up an entire room. You can't put that on a rocket. So they were really, really interested in those first computer chips. But they had to be really reliable because they couldn't fail during the mission, and they had to be really robust to the launch and so on. So they were looking for really good such chips, and the factory in Shiprock, which was actually one of Fairchild's factories, and Fairchild was the ancestor of Intel. So that factory employed almost exclusively Navajo women. The reason the factory was there was actually because there were not many labor laws that applied on the reservation. So it was actually honestly cheap labor. It turns out these Navajo women were amazing at building these very robust chips and designing. They actually designed these circuits that would have lower error rates. And it was very much like the work they did anyway with their hands, with the weaving that they did. So they had this huge impact on building these wonderfully reliable transistor chips. And as we know, this did work, and that led to the success of, for example, the lunar program. So I was amazed that I used to drive by that place all the time, and there is no history left there. There is no real record of this incredible contribution. So that to me was a big surprising moment.
Amazing. Wow. All right. Moving on to our next question from Jane White. Jane says, we all know the story of Marie Curie and how much she gave to her career. What other historical figures do you feel met the bar she provided? This is a tough one, but any others that you'd like to highlight? Shohini?
Well, all of them in the book, I think so. But
yes.
Yes, absolutely. Marie Curie was, she's known and well known because she is absolutely this amazing woman. I mean, reading her story, it feels like, how could one woman be that amazing? But she actually wasn't alone. For example, the chapter in which I discuss her in the book, that chapter is actually not about her, because I wanted to tell the story of this other woman who did exactly what she was working on, which is an early researcher in the field of nuclear physics, who was in fact Ernst Rutherford's first student. And Rutherford is a very famous figure, of course, in physics. And he's the one, for example, who discovered the nucleus of the atom, right? That there was a nucleus. But all of his work, and he, of course, was famous because he also came up with this theory of radioactive decay, and he had lots of contributions in nuclear physics, a huge name. His first student was this woman named Harriet Brooks, who, in fact, a lot of Rutherford's discoveries were based on the work that she did. She also, by the way, independently discovered this element radon. So she has, out of all of the periodic table elements, one of them was discovered by this woman, Harriet Brooks. She also had many other contributions. And for a while, she and Marie Curie actually even worked in the same lab together, because Brooks visited Curie's lab for a while. But there was a huge difference in their trajectories, and I won't say much more. If you're interested, I encourage you to look her story up or read the book. But she's an example of somebody who could have been another Curie. In fact, that's how Rutherford described her. He described her as, somebody, at the caliber of Marie Curie. But she didn't actually get to the level of recognition and achievement that Curie did, and there are reasons for that. So that's one person. The other one I want to mention she's also fairly well known, but should be at the level of Curie in terms of recognition. And she was, in fact, nominated 48 times for a Nobel Prize and never won. And her name is, of course, Lisa Meitner, and she's the one who figured out the theory of nuclear fission, which eventually led to, of course, the bomb, which she refused to be a part of. She was not in the Manhattan Project, one of the few women who was not. But of course, all of that came about because of this theory that she developed. It was also very interesting and infuriating to me that in that famous movie Oppenheimer that just came out about Manhattan Project, they didn't even mention her name. Forget about showing any women. So I'm not a fan of that movie. But anyway.
Wow.
Yeah.
Oh my goodness.
I know there were many other women in that project actually who did work on Manhattan Project, and they weren't mentioned either. But anyhow, so that's Meitner, and there are others, Marietta Blau, who basically kickstarted the entire field of particle physics, because she's the one who came up with the method that was used to discover all these particles. She's not known either, so I could go on and on, but I guess we don't
Absolutely.
have time. So they're all in the book.
I think the best thing is to go read Shohini's book. You can actually, if you take a look at the description below, we have a link to order Shohini's book with the MIT Press. And thank you again so much, Shohini. This has been such an insightful discussion. Thank you for bringing more visibility to these amazing women pioneers. It's been such a pleasure to speak with you today.
Thank you so much. And yes, I encourage everybody to go find out about these wonderful women. And I feel like there's so many more out there too. So perhaps that's one thing we could all do is learn more about women who've contributed and tell our friends. Let's break the code of silence.
For sure. Well, thank you everyone for tuning in, and we'll see you at the next Talks at Google event.
Thank you.